What is up, ladies and gentlemen? Let's take a look at this homework. We got this homework 4.7, which means we are officially one-third away from one-third, excuse me, through our second unit, which means we have a test coming up in about 2 weeks. And that means that's the opportunity you're going to have to make me shave my head bald, or get a pizza party, or hit us with like pies, like in the face for like 30 minutes, which would suck because I'll go home smelling like sour milk. Jeez. Anyway, let's get to this. Let's get some practice in. That's why we're here. Homework is practice, and let's just get to her. Okay, so the manager of a bookstore has found 4 different companies from which she may order book bags. The algebraic rule shown for each company represents the cost of placing the book bag order C. And you know, some of you guys are getting really sharp picking out what these. They're telling you the variables. Based on the number of bags purchased, B. Let's go red. Bags purchased is B. Okay, so we have these 4 expressions. We know C is cost, B is number of bags. So we have to maybe interpret these equations. We will probably do so in the first one. So the first order of business is, change that pen to a thinner version. There we go. For each situation below, write a situation for each algebraic rule if possible. So let's do a little thinking here. C is going to be the cost. B is going to be the number of bags that you're buying. So the numbers have to all relate some way to cost. That's the point I was trying to make in class today. So the 12, this guy right here, this 12 in some way has to contribute to the cost, because that's what we're dealing with right here. Like, we're talking about cost here. Number of bags is covered, so that means all the numbers have to do with the cost of bags in some way. So let's do, if we can do a little interpretation. So if this has related to the number of to the cost of bags, and we're multiplying by the number of bags, think about this. If I bought 12 bags, or let's say I bought 10 bags, and I'm multiplying that by 12, 10 bags times 12, that's 120 probably dollars, since we're talking cost, which means that this 12, this guy right here, green, this guy has to be the cost per bag. Has to be. Because if I take the cost per bag and multiply it by B, number of bags, that's going to give me my cost. I don't have any other way to generate the cost, so that means 12 has to be related to the cost of the cost per bag. So let's write a little scenario, shall we? Okay, so company A means you are getting charged. So cost is $12 per bag. There we go. Nice work. Let's go to number 2. Pitch zoom. Purple. Okay, so this is all about the cost. Well, if the number being multiplied to B in the first example is the cost per bag, I bet that is also the cost per bag, which leaves us plus 55. Now, again, this has to relate to the cost. So 55 has something to do with the cost. This is going to be kind of like an initial fee. Okay, so this could be like, hey, this could be shipping. This could be like the overhead, the tax, like the cost it takes to do business at this store. Like it's a membership fee, maybe, like you have at Sam's. You got to pay $55 before you even walk in the door to buy anything. Now, it kind of makes sense given that we're cost less per bag, but we have this initial fee. So I'm going to write a little scenario here. So the cost is $8.25. I think it's $8.25. Ooh. Focus. Yep, $8.25 per bag, plus a $55 membership fee. Okay. Company C, well, we have a very similar situation going on here. We're going to have this cost per bag of 8, and it looks like we're going to have an initial fee of $100. So let's write a little thing, shall we? Okay, so the cost is $8 per bag, and plus a $100 membership fee. Good work. Green again. Whoa, here's a little different thing here. That's still going to be the cost per bag, but now we're dealing with this negative 55. So this is not like adding to the cost. This is actually like distracting from the cost. So let's think a little bit. Have we ever been in a situation where we had to pay for some stuff and then we got a discount? Like we got some money taken off? That could be what's happening here. Like this is like a discount in some way. Um, Maybe this is like one of those things like J.C. Penney where you get $50 taken off at the register, or you have to bring out and everything is normal price, but then you get a rebate after the fact. That's what's going on here. We have a subtraction problem, so it's going to be a little bit different. And notice this again makes sense because look, we're paying a lot per bag here, so we should get a little discount. So let's see. The cost is, let me zoom in so I can write a little more clearly. The cost is 15 per bag. But you get a, well, how much? $55 discount. Okay, so it's not like one of those percentage discounts that per item. This is like a general at the end. You just get $55 off your ticket kind of bag. Do all 4 algebraic rules fit a book bag situation? Explain your answer. I think so. I mean, if you look, you're just going to be ordering book bags. This could all totally make sense. Like we have to pay for the bags, and then sometimes you got to pay a little more just because that's the cost of like the membership, or you get some discount because of companies going out of business. So I'm not going to write that out, but yeah, I think it does. Absolutely. So let's make a table for each algebraic rule. You know what's going to help? I'm going to rewrite each algebraic rule kind of smallish right above the table. I think that's going to help me kind of instead of having to flip back and forth. So let me do that really fast here. So this one is C is equal to 12b. This is C is equal to 8.25 plus 55. This is C is equal to 8b plus 100. And C in this last one is going to be 15b, $15 per bag, minus a $55 discount. Okay, so we're going to make a table for each algebraic rule. But, we're going to do this intelligently. We're going to use the information we have and we've accrued over the hard work we've done this unit, and we're going to do this really, really intelligently. And here's what I mean. So I know that this number ends up becoming the vertical change in my table. Okay, so if that number is 12, that means each of these has to be a plus 12. Okay, so all we have to do is figure out where to start, and I also know from the information we accrued that this number right here that I'm adding has to be my start value right here. So you're saying, Mr. Collins, well, I don't see anything. Well, you kind of do. It's a plus 0, which means we're starting at 0, which should make sense because if we haven't bought any bags, they're not going to charge us anything. Now, using what I have, one bag, $12 per bag, that's going to be a 12, which follows our plus 12 pattern on the side. So that's going to be 24. Now we have a 36. Plus 4 more is 48. And I'm reaching for my calculator here because I can't seem to do addition right now in my head. And calculator. So I have 12. 12. Clear 12 plus 12 equals 24, 36, 48. Oh yeah, 60, and then 72. That's embarrassing. I couldn't do that addition. Okay. And then let's look at company C. We're going to do the same exact thing we did before. I know that this vertical change has to be my multiplication. And my multiplication in this case is 8.25. So that's going to be the same at every step. Okay, and I know that my start value is going to be this guy right here. So now it's just a matter of putting the numbers in. Okay, so that start value is going to be 55, and I'm going to add 8.25 each time. So 55 plus 8.25 is 63.25. And then $71.50. And then $79.75. And then $88. And then $96.25. Another plus 8.5 takes us to 104.5. So we're just adding each time. Boom, same thing. I don't think I need to do all the fancy color coding. I can do it if you want. Just, hey, pause the video and tell me. No, just kidding. You can't. I'm not even anywhere near this video anymore, but we can still work this guy out. So what I mean is this. This 100 has got to be across from the 0. So that's going to be your start value. And then you got this growth of plus 8 each time. So that will be 108, 116, 124. Let's see, 8 times So 132, 140, 148. Okay. Okay, so that's that table. So this one is probably the most difficult one per se. Ooh, Collins, what are you doing? 0, 1, 2, 3, 4, 5, 6. Okay. And then, so we got their start value, boom, got it right there, minus 55. We need our vertical change. Vertical change is right there. It's going to be plus 15. So if I'm looking to fill out this table, we're going to start at 55 on the negative side, add 15 to it. We should be going up. That means negative 40, negative 25, negative 10. That's a 5. That's a 20. And that's a 35. Okay, not too bad. Now, I'm kind of pointing out that some guys were not evolving their tactics today. So notice that would be a lot harder if we had to plug in points every time, right? So let's graph each algebraic rule. Be sure to scale and label my x's, and I shall do so. Okay, so in all cases, we're going to be graphing two things. We're going to be graphing number of bags and cost, so I can probably fill that in really fast. So number of bags, number of bags, okay? And on the side, which I'm just going to label once and apply to all of them, it's going to be cost, okay? So if we're going to graph all of these, what we really have to do is evaluate the highs and lows. So we're looking at the smallest value and the biggest value, and then it's going to kind of inform us how we want to label everything. On all my examples, we only went to 6. So we can probably space this guy out. So let's go 1, space 2, 4, 5, 6. You might want to pause the video or just let it run as you're labeling all of these, because it's going to be awfully repetitive. 4 and a 5 and a 6, and over here for number of bags we maybe buy 1 or 2 or 3 or 4 or 5 or 6. 1, 2, 3, 4, 5, and 6. Okay, so now here's where it gets a little bit more thinking involved. We have to go from 0, which our lowest, highest 72. So the question is, what do we want to count by? And we can just test some things out. What if I counted by 10, skipping every other one? That's not to count by 5s. Let's see, that'd be 10, 20, 30, 40. This is going to work out. 50, yes, 60, 70. If I can get one more, boom, 80. That definitely covers it. Let's go to this one. Let's get all our labels done. Looks like lowest 55. Now here's the thing. Even though the lowest 55, we probably want to go ahead and start at 0. And the 6 is going to be 100. Okay, so if I look at my previous numbering, that's not going to do it because it only gets to 80. So I have to change what I'm doing. I'm going to try maybe 20s. Like 20s might work. 80. So maybe, let me just do this. So 20, 40, 60, 80, 100, 120. Now I'm not using the whole graph, but sometimes it's okay to leave a little extra around the edges because you never know if you have to expand a little bit. I have to get to 148. I think I could probably get away with 20s again. So 20, 40, 60, 8. Ooh, stop that. 80, 100, 120, 140, 160. Okay, definitely. I only need to get to 148. I got to 160. We're good to go. Here's an interesting one now. I might have to change just a bit. Because if you look, I didn't plan this one too well because I actually have to go from negative all the way to positive. So hopefully you didn't do that in pen. Let's redo this one. Oh, what are you doing? Okay. Anyway, so this is still number of bags. But here's what I want to do. Since I have to go negative, I'm actually going to draw in my x-axis here to allow for some negative. Oh, that's awful, Mr. Collins. Ooh, fix that. To allow for some negative numbers, I have to go from negative 55 all the way to 35. So let's see what we can count by. Let's see, 10, 20, 30, 40. That'll work. So let's count by 10s. Negative 30, negative 40. I have to get all the way up to 35. Let's see. So it'll be 10, 20, 30, 40. That should do. Okay. So let's get to graphing here. Okay, so now it's just a matter of putting the points on the to plot the points. I'll plot them in red. Let's increase the dot size a little bit. Okay, so we got 0, 0, so that's pretty easy. We got 1, 12. Now, if you look, we have to estimate. 1 is here, 12 will be just above. Let's see, 224, same thing. We're just estimating. 224, 3, 36, 4, and 48. It's just 450. Let's see, 5 and 60. Now, hey, here we go. Here's a real point. Boom! I missed. Boom! Okay. And 6 and 72. Okay. Not perfect, but we're just kind of representing the situation. So we got 0, 55 again. We're going to be guessing. It's going to be just below the 60. 1 is 63.5. Now, we expected this one to grow a little slower. 2 is 71. 3 is almost up to 80, pretty close to 80. 4, 88. 5 is not quite 100. And 6 is just over 100. Okay. Company C. This one's going to start all the way up here at Hondo. Then we're going up to 108. 2 is 116. 3 is 124. 4 is 132. 5 is 140. That's a good one. And 6 is 148. Okay, those aren't perfect, but we're just getting close. 0 is negative 55. Now, this is going to cause an issue because I actually have to drop below, so I'm just going to estimate. 1 is negative 4. I forgot to relabel those. Hold on a second. One, 2, 3, 4, 5, 6. Okay. Oh, undo. Anyway, sorry about that. 1 is negative 40, so we can put that, boom, at negative 40. 2 is negative 25. It should be in right between. 3 is negative 10. 4 is a plus 5. And 6 is 35. Okay. If we take a step back, it's what we expected. We have linearity being shown, different rates because they're charging different amounts. Here's your discount, which kind of implies you have to buy 4 per person before you can buy it, before they actually charge you money. But there you go. Lots of work to do with these multiple representations, guys. But if you can do this, bam, you got this test totally in the bag. Let's go ahead into the staying sharp. And I know this video is getting kind of long, but hey, that was a long first problem, am I right? All right, so let's check it out. Write an expression for the perimeter of the rectangle. Make sure your expression is as simple as possible. So remember, perimeter is the distance all the way around. Like if I'm walking, how much am I actually walking? So the first thing we should probably do is do some transferring. It's a rectangle. So that means this side is 5x plus 9, and the bottom is going to be 3x plus 12. And so if we're talking about perimeter, pretend this guy is me, and we just walking. So check this out. We walk this much. How much did we walk? That is going to be 5x plus 9. Second thing, now we're walking this way. Boom. How much did I walk? Well, it's going to be this guy right here. So we're going to add 3x plus 12. Keep this cavalcade fun going. Now, ooh, no, you stay. You stay where I put you. Okay, ooh, I lost my feet. Walking down there. That's another 5x plus 9. And my final little jaunt back to my starting position. I'm going to walk a final 3x plus 12. Now it's a matter of doing some like term combinations. So here's something with an x, here's something with an x, here's something with an x, and there's that thing. So let's add them all together. We got 5 and 3 and 5 and 3. That's going to be 16 x's. Boom, boom. Okay, other part of it. We have 9 and 12 and 9 and 12. Those are all numbers. We can put that together. So let's see, 9 and 12 make 21. Do it twice, you get 42. So that should be a plus 42. So that's what the perimeter equals, 16x plus 42. Write an algebraic expression to represent each phrase using n to represent a number. Rewrite the expression more simply if possible. Okay, let's try it. A number plus itself, so that's going to be n plus n because n is used to represent a number. I can rewrite that as 2n. A number times itself, I can write that as n squared. A number minus itself, I can make that to be 0 because anything subtract itself off is 0, and a number divided by itself, n over n equals 1. This is crazy important. If you don't know these 4 things, you will not survive math. Put a star by that one. Make sure you know how to do this guy. This problem right here. Nicole's mother says to a friend, if you triple Nicole's age and add 16, you get her grandmother Gladys' age. Write an algebraic rule and it tells you what to use for the variables. N for Nicole's age. G for Gmar's age. Let's get to it. So if I take Nicole's age, N, add 16, and then, oh, I'm sorry, let's try it again. If I take triple Nicole's age, 3N, then add 16, you're going to get her grandma's age. So 3N plus 16 is equal to G. If Gladys is 67 years old, how old is Nicole? Okay, so Gladys is 67 years old, so they're asking us to replace that G with a 67. So what I'm looking at is 3N plus 16, but instead of G, we're going to actually now write a 67. So now we got to solve. So if 3N plus 16 is equal to 67, if I take 16 away from Nicole's age, that means Gladys is essentially 16 years younger too. So my first step is to subtract 16 on each side. Boom! So we're left with a 3N on this side. 67 minus 16, well, that's going to be a 51. Okay? So if I take 51, if 3N's make 51, how much does 1N equal? So that means 1N equals 17, because 3 of them make 51. That's a division problem, by the way. So Nicole should be 17. And we can confirm that. If we take 17 and we triple it, whoa, get out of here, crazy line. Get out of here. Take 17 and we triple it. That's going to equal precisely 51. And then if I add 16 to it, 6 plus 1 is 7, that'd be 67, I guess 67. And you kind of call this working backwards. Okay. Caitlin is 62.25 inches tall. Her older brother Jamie is 9.5 inches taller than Caitlin. Jamie is 2.5 inches shorter than her father. How tall is her father? Show your work. Okay. So first of all, let's convert some of these to decimals. That'll be easier to work. So 62.25 is 62.25. 9.5 is going to be 9.5, and 2.25 is going to be 2.25. Okay, so let's try this out. Caitlin, which I'll call orange, is 62.25 inches tall. Her older brother Jamie is 9.5 inches taller than Caitlin. So if I take hers plus 9.5, I get Jamie's. So Jamie, well, that loopy J, that could loopy J. J is going to be this addition problem, 62.25 and add 9.5. That means Jamie is 71.75 inches tall. Okay. Jamie is 2.5 inches shorter than her father. So if I take 71.75 and I subtract off 2.25, that should be her father's height. So I'll subtract off 2.25 and I'll end up with 69.5. Get out of here, air server bar. Right, last problem. Let's go. Find two different fractions whose sum is equal to 1. Dude, I can do this all day. Check this out. So two different fractions whose sum is equal to 1. We'll check this out. 1/3 plus 1/3 plus 1/3 equals 1. I could do this, look, you only want two fractions? 2/3 plus 1/3 equals 1. If I have 1 of something and 1 of something and 1 of something, I get the whole thing. It's divided into 3 parts. If I have 2 out of the 3 parts and 1 out of the 3 parts, I have the whole thing. Thirds are boring. Let's go to like sevenths. Check this out. 6 sevenths. So I have 6 out of 7 pieces, and I found the last out of 7 pieces, I have the whole thing. Or if I have 4 out of the 8 pieces, and then I add another 4 out of the 8 pieces, I have 8 out of the 8 pieces, which is 1. Okay, so any of these fraction combos would work. Point being, if you get the numbers added on the top to be the total, same as the bottom, you have the whole. Guys, that was a long one, but you know, kept it under 25. Hope it helped. See you guys later. In my head, I'm just sweating right now. Man, I hope my hair length changes dramatically soon. Bye.